Hello everybody and welcome back. We're going to take a look in this video at question number 2 on the 2008 Fryer paper. We just saw question number 1 in the last video, and now we're moving on to question number 2. It's a nice little 3-part question. How about we take a look? So, if a team won 13 games and lost 7 games, its winning percentage was 13 divided by 13 plus 7 times 100% equals 65%, because it won 13 of its 20 games. So the total number of games won, which is 13, over the total number of games played. 13 games won and then 7 games lost gives us a total of 20 games. So part A. The Sharks played 10 games and won 8 of these. Then they played 5 more games and won 1 of these. What was their final winning percentage? Show the steps that you took to find your answer. Okay, so to figure out the winning percentage, we need, first we need a brand new piece of paper. It's a winning percentage. Oh, it's still in another color. That's okay. So our winning percentage, nothing wrong with the red pen, by the way, I just prefer to keep everything in black. So this is sort of their average, almost. So number of games won over number of games played times 100%. So our team won 8 games and then 1 more. So overall, they won 9 games. And I think they're called the Sharks. So they played 10 games and then another 5. So they won 9 games, they played 15 games. Winning percentage, 9 divided by 15 times 100%. You can get out your calculator if you want to. You'll notice that 9 and 15 have a common factor. So it becomes 3 over 5, and that gives us 60%. So we can put a little box in there, or we can make a therefore statement, either or, just anything that lets the marker know we've got our final answer. Okay, B part. The Emus won 4 of their first 10 games. The team played X more games and won all of these. Their final winning percentage was 70%. How many games did they play in total? Show the steps you took to find your final answer. Okay, so if they played X more games, then that'll be added to the 10 games they've already played. And if they won 4 games and then won X more games, each one of the X additional games they played, they win. That tells us the number of games overall they won is 4 plus X. That allows us to equate that to the winning percentage they give. So 70% should be equal to 4 plus X, the number of games they won, over 10 plus x, the total number of games that they played. And I remind you, we want 10 plus x. We want that for the final answer. So we're going to need to figure out what x is. Times 100%, just to keep sort of the percent units all in play. So we can start equating these and figuring out both sides. I'm going to drop the percents because we don't really need them. You can keep them in if that's your preference. Okay, so it's basically what we're doing is we're just bringing this denominator over so we can get a single linear equation in x, and it should be very easy to solve. So this gives us 700 plus 70x equals 400 plus 100x. Well, we can rearrange these, get the x's on one side. So we get 700 minus 400, so that'll be 300. We'll get that in a moment. And then 100x minus 70x. So 300 is the same as 30x. So x is 300 over 30, which it's not that hard to figure out using your calculator or any other means that x is going to be 10. And we could mentally check that up here. If x is 10, then they've won 14 games and played 20. 14 divided by 20 will give us 70%. I think they were the emus. I'll check when I look at the next question. So we give a little final statement because they asked for the overall number of games, not the value of x. Alright, and yes, it was the emus. Fantastic. Okay, last part, unless there's something on the next page. No, there isn't. C. The Pink Devils started out the season with 7 wins and 3 losses. They lost all their games for the rest of the season. Okay, so this sits in contrast to B part, where they won, where the emus just kept winning all their games. So the Pink Devils have lost all their games for the rest of the season. Was there a point during the season when they had exactly won 2/7 of their games? Explain why or why not. Okay. So the best way to do this is to try and set up an equation. Start by saying, well, what if there was a point where they had won exactly 2/7 of their games? What would that look like? How many games would they have played? And so we can set it up very similar to B part. We can say let y be the number of games they played until they got 2/7. And we can try and set up an equation and show why or why it won't exist. Okay. So we start on a fresh page. Right, suppose they've won 2/7 of their games after playing y additional games. Every other game they play after their first 7 plus 3 equals 10 games, they lost. So 3 games lost, 7 games won, and then they played Y more games, which they all lost. So that's 10 plus Y. So then we know 2 out of 7 games is the ratio of games that they've won. So that should be 7 over 10 plus Y. So it's a matter of isolating Y on the one side and seeing if we can solve for it. So 2 times 10 plus Y equals 7 times 7. Now if you want to, you can stop there and take a moment to see if you can see Y. This number on this side is going to be 49. If we're familiar with our squares, we know that right away. If not, we can punch it in our calculator. This side is going to be 2 times something, 10 plus some number of games. So this side, 49, is odd. This side is going to be even. So no matter what choice of Y we could have, this equation can't be satisfied. And you could explain that. You really could, and you'd get excellent marks because that's a nice observation. But if you didn't want to, or if you didn't see that right away, that's okay. We can still rearrange the whole equation. Okay, so we get 20 plus 2y equals 49. 2y equals 29, and at this point it should be very apparent that no possible y value can work here. But we can continue on. So we get a nonsense answer. They can't play 29 halves of a game. So they can't play 14 and a half games, which is what this y should be. That's impossible. We have a nonsense answer out. Now, none of the math can be wrong. The math was very methodical. We know the number of games they won. We know the number of games they played. So we set up this equation. We should be able to manipulate down and get the value of y. But if the value of y is a nonsense answer. So since there can't be anything wrong with the math in here, the only thing that can be wrong is our assumption that after playing y more games, they have won 2/7 of their games. So this is known as proof by contradiction. Okay, our assumption was that at some point they do get 2/7 of their games won. All right. So it's a nice quick proof by contradiction. We assumed something. If it had worked out, if we had gotten y to be a number, maybe 13 or 14 or something like that, then we'd know, yes, at some point the Pink Devils had a winning ratio of 2/7. But we didn't. We got a nonsense answer. And since the math flowed very logically, there couldn't have been a flaw there. So the only place there could have been a logical error was our assumption that they had at some point won 2/7 of their games. So it contradicts, it's a contradiction. The final answer contradicts the original statement. They couldn't have played y more games. Y is a nonsense number of games. And that wraps up question 2 nicely and neatly. Good little question. I rather liked it. You don't often see a lot of percentages and probability stuff in a lot of school, especially as you get into high school. So these sorts of questions are actually quite nice. Hopefully you guys have enjoyed it, and hopefully you'll join me for the next question on the 2008 Fryer paper. Until then, I'll see you guys next time.